So we started talking about a lesson 11.7 yesterday, and we started off with multiplication and basically involving binomials and radicals. And guys, look again, normally in these, we're not giving you anything extremely difficult. You got to get over the mental block of radicals. If it's a square root, if you have two of the same factor, you can take the square root of it. It comes out as one of them. And so the only big deal is some simplifying. Of course, there's always the possibility of a mistake, but a mistake is just a mistake. You know, if you make a mistake because a plus times a minus and you put a plus, well, that's just a mistake. You know what to do. You just got to be more careful. But make sure that you understand the procedure. Then we started talking about how to divide by a binomial. And the point was we have to multiply by the conjugate. We have to multiply top and bottom by the conjugate. Not just by the radical. That won't work. And at the end of yesterday, I showed you how if you try to multiply b by just the square root of 2 on the bottom, you still end up with a radical on the bottom. You can't do it. And so here's the recognition. You as a student, you come across a problem like that and you say, oh, I got a binomial in the denominator. To rationalize the denominator, I got to use the conjugate. That's the thought process. So one big tip, though a lot of you won't take me up on it, is to use the parentheses. Because again, these are two binomials. So you can see why this lesson, why dividing comes in with the multiplying. Because you got to multiply these binomials. Okay, whenever I do rationalizing with the conjugate, I always figure out the denominator first. Let me try to explain why. Don't write any of this. This isn't the case. But let's just suppose that when I'm done with the whole denominator, now this isn't the case, but let's suppose if when I finished multiplying the whole bottom out, I got the number 10. I would want to do the denominator first because guess what? In this example, I could reduce these. Right? And therefore then not waste my time multiplying this 5 out, unmultiplying it to factor it, and then reducing. Do you follow? So again, with these, I always do the denominator first. Will they always reduce? No. But when they do, you want to reduce them before you multiply. For that reason, I always worry about the bottom first. Now, you can do it another way. I'm just telling you that's the most efficient way, and that's the way to make sure that you simplify them. All right, so let's go ahead and do the bottom here. It's a difference of two squares. We can take the shortcut, but what happens when students take the shortcut? After a while, they think every binomial multiplied times a binomial, you can take the shortcut. So be careful. Be careful. I'm not going to take the shortcut. What's the square root of 2 times the square root of 2? 2. I am going to show the shortcut using color, though. Let's do the second multiplication in red. So now take the square root of 2 and multiply it times a negative 1, and that's negative the square root of 2. Do you agree? So we distributed the first term of the first binomial, stay in red. Now multiply the positive 1 times the square root of 2. And what do you get? Positive the square root of 2. Do you see how those divide out to 0? They always do with a difference of two squares. Always. They're always 0. Always with a difference of two squares. So then take your blue and finish off now. We still have to distribute the 1 to the back, right? So again, what's a positive 1 times a negative 1? And in this case, it is a negative 1. So what's our denominator? 2 minus 1, all right, is a 1. Real boring. I wouldn't even put it. But I'll just leave it there for emphasis. So on this one, we have to finish out by distributing the 5. So what's 5 times the square root of 2? Guess what? It's 5 times the square root of 2. And what's 5 times a negative 1? A negative 5. Final answer, we wouldn't leave anything over 1. Would I factor out the 5 to write my final answer? Would I? Would I factor out the 5 to write my final answer? Would I? Yes or no? Give me a verbal, yes or no. The answer is no, because remember, factoring is a means to an end. You're unmultiplying. Factoring's a means to an end. We only factor if it'll get us something. And in this case, it doesn't. All right, so 5 times the square root of 2 minus 5 is the final answer. One more time, please understand these parentheses really are important to make sure that you understand that you're multiplying times the whole binomial. And if you don't put them there, then there's a good chance you're going to make a mistake. So don't do that. Okay, let's go to the next page. All right, so we already talked about all that up above. I wanted it on this page again so you could see it. So I want you to go ahead and write in what you're going to multiply this by. Don't do any of the figuring yet. Just write in what are you going to multiply this by. And I like to do it in green. So go ahead and do that. What are you going to multiply? So Ashton, what do you want to multiply by?
Parentheses 5 plus the square root of 3.
Awesome. 5 plus the square root of 3. And I agree. Let's put it in parentheses. Whatever we do at the bottom, let's do the same thing at the top. I'm keeping my parentheses. And not only that, I'm going to put this one in a parentheses, right? All right, so go ahead and finish it off now. Go ahead and finish it off. The bottoms are going to be the key. If you need help, you can look up here in the process. I'll be doing it on the bottom in the process. But see if you can do it. So again, if you're a thinking person and you think, oh, there's a difference, 2 squares, I can do the shortcut. Okay, do it, because you're thinking that. And it is easier to use the shortcut, front times front, back times back. But think that. Think in your brain as you go to do the shortcut. This is a shortcut for a difference, 2 squares. And that way, you're not going to fall in the trap of then next time treating regular binomials that way. All right? Now, how many got 22 on the bottom? Now, if you didn't, I need you to talk to me and ask me some questions so I can help you. Questions. Questions. What are you missing that you didn't get 22 on the bottom? Alexis? Uh-huh. So I took the shortcut. So I'll do the rest in red. When I do that second distribution, I get a positive 5 times the square root of 3 on that one, and I get a negative 5 times the square root of 3 on that one, and those always add up to 0 for a difference 2 squares. Positive 5 times the square root of 3 minus 5 times the square root of 3 is 0. So I'm left with a 25, the stuff in the middle is 0, and a negative 3 on the back, and therefore I'm adding the 25 and the negative 3 on the back. Now, did you get that in the middle, Alexis? A 5 times the square root of 3 and a negative 5 times the square root of 3? Okay. So, let me go back for you. Here, let's just get rid of this. So, on your first distribution, did you get 25? Okay, yes? Okay. On the second, did you get positive 5 times the square root of 3? Okay, so this is, examples will get you there. All right. Other questions from somebody else? You saw now a lot of intonations of that. So, all right, let's see if we can care for the next one. And notice I'm showing you a little bit different scenario each time. Because that's the thing with math. Same concept, a lot of different looks. All right, so go ahead and multiply by the conjugate over the conjugate. And again, you work through it. I'll work through it up here while you're working through it down there. And we'll see if we end up in the same place. If you need help, look up. But if you don't need it, try not to look up. Ooh. Gotta always be thinking. Did you end up with a 7 minus 1, which is a grand total of 6? Did you then, therefore, reduce before you multiply that top? And you should. You should. That gives me a 2 on the bottom and a negative 1 on the top. Finish it off, distribute your negative 1. So now we have negative the square root of 7 plus 1, all divided by 2. How many got that correct? And if not, do you see what caught you? You see what you missed? If you didn't reduce it right then, you're going to have an equivalent value, but it's not going to be reduced, and we need to reduce them. So it was way to our advantage to do that denominator first, because in this one it did reduce. And if you don't figure the denominator first, you're just real quick to multiply the numerator at the top. Well, now you're going to have to unmultiply it back out to reduce it. And you're just wasting time. And you know what normally happens? Students don't unreduce it. They don't factor it back out and they leave it there. All right, let's try another one. All right, similar situation. You guys work on it. I'll do it up here as well. If you need help, you can look up here. Try to pay attention to detail. Kirsten.
For the one up there, you would reduce both of the threes? Like the one
Both of what threes?
The one multiplied by the square root of 7 and the one that's added at the back. What does the so when you distribute the negative 3, you get to the top you get negative 3 times the square root of 7 plus 3.
So let me show you where we're at when I get the bottom. I still have a negative 3 on top of that one. And I still have a square root of 7 minus 1 there. And on the bottom, I'm sorry, I had a 6, right?
Yes.
So this negative 3 and this 6 reduce. And that makes this front a negative 1 and this bottom a 2.
Oh, okay.
And it's that negative 1 that I'm distributing. Okay? Again, I'm using the shortcut, but I'm thinking, hey, I can do it because it's a difference of 2 squares. I hope you got a negative 5 on the bottom. All right. Do we leave negatives in the bottom, class? So isn't it better right now to stick it on the top? Yep. I'll just make it a plus and make that 2 a negative 2, right? I'll put the negative on the top instead of on the bottom. I will now distribute the negative 2. So that's a negative 2 plus 2 times the square root of 6 all over 5. How many got that one correct? Okay, questions. 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 Kaylin.
How is the second one at the top positive?
Because a negative times a negative is a positive. Do you agree? Did you wait to do your negative later, Kaylin? Did you have it in the bottom in the beginning? Okay, so watch. Let me show you what would have happened if I left it in the bottom. So if I left it in the bottom, my top would be 2 minus 2 times the square root of 6 over negative 5. Now, everybody should be paying attention to this because I still have Algebra 2 students making this mistake. And this is what they do. And that's wrong. Because you chose only part of the numerator to change. That is correct if you're going to do it at the end. Therefore, final answer, negative 2 plus 2 times the square root of 6 over 5. Okay? Because, Kaylin, technically, you're multiplying the bottom by a negative 1 and the top by a negative 1 to take that negative from the bottom and put it in the top. Okay? Other questions? Again, I'm trying to show you all the things that can trip you up so you see them and they don't trip you up. All right, now you have 2 radicals on the bottom. All right, and you also have a radical on the top. So be careful. There are some things that'll trip you up here. Be careful. We know how to do everything. Go ahead and do it. Again, you do it at your seat. I'll do it up here. If you feel like you're stuck, look up. If you feel like you can keep going, keep going. You might want to look up after you get the bottom to make sure you got the bottom correct. If only I had the time to develop it, but oh well. So again, if you're stuck, take a look up here. Again, I'm doing the shortcut each time because I realize that it's a difference of 2 squares. So you should have gotten a 3 on the bottom. This one's not going to reduce because you got a radical on the top anyhow. But there is one more pitfall, right? Yes, one more pitfall. So square root of 2 times the square root of 5 is the square root of 10. But be careful. What's the square root of 2 times the square root of 2? So I hope you got a 2 there. How many got that one correct? Oh, good. Bunch of you. Bunch of you. All right. Hey, you guys, always keep in your mind, simplify, 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 ratify, homogenize. All right. Try G. Last one of this lesson, not the last note we're going to take today. Again, you work G. I'll work it up here while you work it back there. If you need to, take a look up for help. Again, I'm always just showing the shortcut because I'm thinking this is a difference of 2 squares. I can do the shortcut. I'll be safe. You guys will pause for a second, look up here. I don't know if you got -4 in your denominator. You should. To be honest with you, I could take care of the negative right now, but because I have, and by the way, I need one more parentheses here, because I have two binomials in the top, I'm just going to do the negative at the end. You could do it now, but on this one, it's just because of the situation, it's different. I'm going to do that negative later. All right, you can keep working, see if you end up in the right spot, or you can look if you want. See, did you already forget that you're multiplying binomials? Did you do the shortcut on the top? The top is not a difference of two squares, right? It is not. Okay, there was no simplifying, though, on the top. So again, technically, if I change this to a plus, that negative's out in front of this whole thing, meaning it changes the sign of everything in the top. And in this case, everything now ends up negative, because for this example, everything happened to be positive. But things that were positive would go negative, things that were originally negative would go positive. All over 4. Anybody get it? Okay, good. Good. Questions? Questions?